Hello everyone. Now that we have understood atomic structure, we will see how these atomic structures organize into the periodic table, and how this organization of the elements in a periodic table reveals patterns in chemical and physical properties. And the atomic table is a systematic chart of all non-elements, and these elements are organized by increasing atomic number. And when we arrange all the elements in this way of increasing atomic number, elements show a periodic repetition of their uh, chemical and physical properties. The key arrangement of a periodic table uh, are period groups, blocks, and period groups and blocks. The periodic table, there in a periodic table there are 7 rows. Every element in a given period has the same number of electron cells, or the energy level. So within all the horizontal, within the same horizontal rows, all the elements will have the same number of electron cells or same level of energy. For instance, every element in, if we say period 3, has electrons filling the first 3 principal energy levels. And then we have groups, which are basically the columns of the periodic table. There are 18 vertical columns, and elements in the same group are also called families. It's either called groups or families. And elements within the same column share very similar chemical properties, and they have the same number of valence electrons uh, in the outermost shell. So within the same column, or we can say within the same group, elements will have same number of valence electron. And in last video we explained that these valence electrons are the main property of an atom that defines the chemical reaction of an element. So within a same group, the valence electrons are same, so so all the elements within the same group have similar chemical properties. And then we also have the elements arranged in different blocks, and these blocks are S, P, D, F, based on the orbitals from quantum mechanical model, and corresponding to the type of atomic orbital, and that is being filled last in the region. So for the S block, the last last orbital will be S. For P, the last orbital will be P, and so on. uh, the periodic table can also be divided into this three classification, namely metal, non-metal, and metalloids classification. The periodic table was first introduced by Mendeleev, and this periodic table is also called Mendeleev's periodic table, and its full name was Dmitry Mendeleev. And when Mendeleev introduced this periodic table, he was so confident in the periodic law that he left gaps in his table, and he also accurately predicted the properties of elements that had not yet been discovered, and the discovery of this new element, which the of which the properties were already predicted, shows how powerful the theory of this periodicity uh, periodicity is. Now let's look at the periodic table, and we can see here we have 7 rows, and these are the period is also here. So all the horizontal rows are period, and all the vertical columns are grouped as groups. So we have 18 groups and 7 period, and we can also see the first two here. This is S block, and we also have this F block here, and this lanthanides and actinides are separated from here to make the periodic table more easy to read, and this F block are here, and then we also have D block. All this blue section is D block, and yellow section is P block. And if you look at this periodic table, we can say S block is all the groups from 1 and 2. D block is from 3 to 12, group 3 to 12. P block is from 13 to 18, and there is an exception here, helium. Helium is, if you look at this color code, this is also S block. The element helium also belongs to S block. And I have shared interactive periodic table from Britannica library. So I want you guys to go through this link here and play around and learn more about a periodic table from an interactive periodic table. Let's see here. So this is the if you click on the link, this is where it will take you to the Britannica.com is a encyclopedia. So this periodic table is interactive, so you can click on element and learn more about the element. For example, here if I click on hydrogen, the symbol is hydrogen, electron, it will show all this different information: atomic number, atomic weight, melting point, boiling point, physical state, electron configuration, symbols, name, etc. And if you want to also learn about, for example, different properties, if I click metal here, alkali metal, so we can say the elements in the first group are called alkali metals, and the properties of this alkali metal is that when they react with water, they form alkalis, and alkalis are strong bases that are capable of neutralizing acid and forming neutralizing acids. Similarly, if we click on alkali like metal, we can see the second group, the second group, the metal in second groups are called alkaline metals. Similarly, this whole block of this color element are called transition metal. And the property of transition metal is that these elements are hard, strong, and lustrous metal. And the metal we are familiar with, for example, uh, iron, cobalt, nickel, copper, zinc, all this metal we are familiar from our day-to-day life belongs to transition metal. Similarly, rare earth metal, these are the metals we use for example, semiconductor industries, for batteries or chip manufacturing, etc. And then uh, furthermore, we also have metalloids. Uh, Basically, these are the elements that forms semiconductor, which are the building block of all the chip manufacturing, GPU, CPU, all these chip manufacturing. And then at the end of the table, we have noble gases: helium, neon, argon, etc. And these are colorless, odorless, tasteless, non-flammable gases because their outermost shell is completely filled. So basically, they do not react with anything. So they are colorless, odorless, tasteless, non-flammable gases, and so on. So you can look at this interactive table to learn more about periodic table. And after that, as we say, we can classify all these elements into three categories, namely metal, metalloids, and non-metal. Uh, if we look at this table here, all these materials are color coded. This red or orange this color is all the elements in this color are metal, and then all this blue color are non-metal. And if you see here a dark staircase looking line here, all the elements with nearby this line is sometimes also called uh, metalloid staircase. Staircase, all the elements in green color nearby these stairs are metalloids, and all the blue colors are non-metals. And the properties of a metal are that uh, metals are an excellent conductor of both heat and electricity. And their characters their other characteristics includes that metals are mostly malleable and ductile. So malleable is when we can hammer the metal and make it a thin sheet. Or metal and metal are also ductile. And the ductile property of metal is what makes makes it uh, makes it possible for us to make a wire out of metals. And most of the metals are solid at a room temperature. There are some examples which are liquid in even in room temperature. For example, mercury is the most common example. We see it as a liquid, even though it's a metal, in a atmospheric temperature and pressure. And metals are also highly reactive, especially alkaline metal. And then we also have transition metal here from group 3 to group 12. these transition metals has a property between highly reactive metal in this group 1 and group 2 and metalloids here nearby the staircase. And these transition metals are includes the metal we are mostly familiar with, for example copper, iron, zinc, etc. And then the materials can be classified into metalloids, and the metalloids name the meaning of metalloids is basically metal like, and this materials has a property in between metal and non-metal, and these materials metalloids are technologically most important characteristic, and they have this most important characteristic of a semiconductor, where if you fulfill certain requirement, then they will conduct, they will act as metal, otherwise they will act as non-metal. And one of the most common metalloid we hear about in most of the technological field is silicon. Silicon belongs to a metalloid. And then we have non-metals, the blue area in the table, and this non-metal have the properties that are opposite to metals, meaning they are very poor conductor of both heat and electricity, and they can exist both in liquid, solid or gaseous phase, even at room temperature. Now let's look at the most important trends and most important trends, or we can say periodic properties. These properties vary predictably across the table and explain why elements react the way they do. And let's start with the atomic radius. Atomic radius is the distance between two nuclei of same element. Here we can see in the figure we have two atoms, and the atomic radius is the distance between two nuclei of same atom. And this property, the trend of atomic radii is driven by two factors. Atomic radius is driven by two factors, and across a period. Across a period in a periodic table, the radius decreases. Meaning, if we go from left to right in a periodic table, the atomic radius decreases. And if you ask why the atomic radius decreases, if we go from left to right, it is because as you go from left to right, because the periodic table is arranged in increasing atomic number, and we also know within the same period the energy level is same. That means for the same energy level, if we are increasing the atomic number, that means we are increasing the number of protons. And since the number of protons in the nucleus of an atom increases, the electrostatic force of attraction between the positive and negative charges increases as we move from left to right across the period. Similarly, if we look in the periodic table, and we go from in a same group, if we go from top to bottom, down a group, the radius increases because we are moving from one energy level to lower energy level to higher energy level, essentially increasing the distance between the nucleus of two bonding atoms. And then we have ionization energy. This ionization energy is defined as the energy required to remove an electron from an atom, or in other words, we can say this is the energy required to form a cation, meaning we have less electrons and more proton, resulting in net positive charge. So ionization energy required to remove an electron. And if we look at the trend of property across a period from left to right, the nucleus the ionization energy increases as we go from left to right, and the reason for the increase in ionization energy is that the nucleus, as we said from this example, the electrons are attracted toward the center more strongly as we move from left to right, meaning it will require higher level of more energy compared to the elements in the left group of an element. Similarly, if we look at a column, and if we go from top to bottom, the ionization energy decreases, and the reason for this decrease is because as we move from top to bottom, the energy level increases, meaning the electrons are farther away from the nucleus, resulting in lower electrostatic attractive force, and resulting in lower ionization energy. And then electron affinity is the energy this is the energy change when an atom gains an electron. So ionization energy was the energy required to remove an electron, and electron affinity is the energy change when an atom gains an electron. And in other words, if ionization energy was defined as the energy required to form a cation, electron affinity can be defined as the energy gain when the atom is converted into anion. And across a period, electron affinity becomes more negative, releases more energy, meaning the atom has a higher tendency to gain an electron to fill its balance cell. So more negative across the period, less negative from top to bottom. And then we have electronegativity, and this is the measure of an atom's pulling power. Electronegativity is the ability to attract electrons to itself when it is chemically bonded to another atom. And the trend of electronegativity in periodic table is to similar to ionization energy. So the ionization energy and electronegativity has the same trend within the uh, in the periodic table, and the highest uh, electronegativity, the element with highest electronegativity is fluorine. And if we see the trend, uh, if we go across the period, the electronegativity increases. If we go down a group, it decreases. And electronegativity is useful in explaining the bond polarity of a bond polarity in a reaction. We will talk about this in upcoming chapters. And the next property of periodic property in the periodic table is ionic radius. Ionic radius is the size of an ion uh, it the atomic radius was the size of or the distance between the nucleus of two atoms, and the ionic radius is the distance between two nuclei of ions rather than atoms. And if the ion is positively charged, positive ions are called cations, and the cations are always smaller than the neutral atoms, because they have lost their outermost shell of electrons. And if you look at anions, which are negative ions, and if you look at anions, the ionic radius of anions are always larger than the neutral atom, because adding electron increases the spreading, increases the repulsion, and it spreads the electron clouds out, because we have more electrons. We can see here, instead of a neutral electron, now we have ion with positive charge and negative charge, and this is the radius. Instead of distance between two nuclei, this is the radius from the outermost shell to the nucleus of an ion. And then the periodic nature, metallic and non-metallic characteristics, we already talked about it in the previous slide. Now let's summarize all this property, and we can see atomic radius increases as we go from top to bottom, and uh, top to bottom, or right to left. And ionization energy and electron affinity has similar behavior. uh, it will increase as we go up a group or across a period from left to right. Similarly, a metallic character, we saw that these two blocks are the most active metal. These are non-metallic, and somewhere in here lies the metalloid, which has property in between metals and non-metal. And the application as we said, Mendeleev, when he proposed the periodic table, he left spaces for unknown materials with predictable behavior, and when scientists discovered those elements filling in the gaps, the property uh, Mendeleev predicted was similar to what they observed in the newly found uh, material. That means periodic table is very applicable in applicable and very important in very important tool for predicting the property of a material, property of element. And if we want to point out all the applications of periodic table, first we can say we can predict reactivity. For example, group 1, we said group 1 is alkali metal, and they have the lowest ionization energy, so we know they are the most reactive metals. And when they when water when they come in touch with water, they explode and readily lose one electron, forming an ion. Similarly, we can also predict the type of bond based on the valence electron of an atom. We can also predict what kind of bond it will form when there is a chemical reaction. And then we can also predict material properties, whether it's metallic, metalloid, or non-metallic. And like we said before, periodic table can be used to identify uh, unknown material, to predict the behavior of unknown materials.